In this video, we're going to look at the graphs of secant and cosecant. I'm going to start with cosecant just because we generally start with sine, and the graph of cosecant is related to the graph of sine in the same way that the function cosecant is related to the function of sine. In fact, the function cosecant is 1 over the function of sine. So by way of remembering that, we have the cosecant of x is equal to 1 over the sine of x. And that's actually what we're going to use to graph this. I'm going to do this fairly quickly because this graph and the graph of secant are a little bit they're hard to distinguish one from another. There's a way to do that. And other than that, they're pretty straightforward. So here's how I do this. Here's how I think of this. Since the cosecant is 1 over the sine, all the values on the graph of cosecant are going to be the values 1 over whatever the value was for sine. So, for example, here I have a value of 1, an output value of 1. 1 over 1 is 1. So the graph of cosecant is going to have a point right there. Now, here, let's see, where is the value a half? It's at about pi over 6. We didn't get very many marks here. Here's pi over 4. And then here's pi over 6, and here's pi over 3, approximately. So at pi over 6, the value of sine is a half. 1 over 1 half, 1 over 1 over 2 is 2. So at pi over 6, cosecant has a value of 2. At pi over 4, sine has a value of the square root of 2 over 2, and that's about 0.7. But the cosecant is 1 over that. So let's see, I'll use my calculator again. That's 1.4. So at pi over 4, cosecant has a value of 1.4, which is about there. At pi over 6, the sine function has an output value of 0.866. 1 over that is 1.15. So 1 over sine is 1 over 0.866, which is 1.15, which is about there. So this graph has the behavior that you see here. Let's talk a minute about what the graph of sine is doing at 0. When the input value is 0, sine of 0, the output value is also 0. Well, 1 over 0 is undefined. So in fact, there we have an asymptote. At 0, we have an asymptote. There we go. And in fact, at pi, sine is 0. 1 over sine is going to be 1 over 0. So the cosecant at pi will also be 0, and we'll have an asymptote there. And we'll have an asymptote here and here. Anywhere sine is 0, 1 over sine, cosecant, is going to be asymptotic because we can't have 1 over 0. So there are all the asymptotes, at least on the part of the graph that we can see. Remember, this graph goes on forever in both directions. But for the part of the graph that we can see, I've put asymptotes in for every place that sine is equal to 0 because cosecant there is 1 over 0, which we can't have. Now, if I continue this process, I'll get for this side of pi over 2, I'll get the same values as I got for this side of pi over 2. Because the sine graph is symmetric, the cosecant graph is also symmetric. So I'm going to have values that match. I'm going to have a value of 1.15 about there. I don't remember what the actual values were now, but there's one there, and these just match what I had on the other side, and so this graph does this kind of behavior. And now we know that that's actually asymptotic. And that behavior is going to repeat in every region of the graph in which there is a positive value for the sine function. I'm going to get something that looks like this. Doing the best I can here. I'm definitely not an artist. There we go. There's the last one. So what do you think is going on down here? And the answer is pretty much what's going on up here, where we have a sine value of -1. 1 over sine is also -1. So we're going to have a -1 there and there. There's going to be one over here as well, but we can't see that. And then because we're in quadrant, let's see, here we're in quadrant 1 and quadrant 2. Sine is positive in both of those. Sine is negative in quadrants 3 and 4, so we're going to be negative here. And we get the same values, right? We get the same values for sine, so we get the same values for 1 over sine, except that they're negative. So we're going to have this behavior, but down here instead. So the complete graph of the cosecant looks something like this. Now, as I've said, I'm not an artist, so this is a pretty rough sketch. Here's a better one. You can see the original sine graph, and you can see in black, you can see the values or the graph of the cosecant. All right. You can't actually see asymptotes here, but we know they're there, and the behavior is asymptotic, so we can believe that that's the case. These are all asymptotes. And you can tell that this is cosecant because even without the sine curve there, the implication is that sine is 0 here, which means there's an asymptote at 0. All right. If this was cosecant, we'd be starting here, and we'd have a 0 value here for cosine, and so secant is going to have an asymptote here. That is actually all I'm going to do for this video, because we can cover the secant graph, which is 1 over cosine, in class. The process will be exactly like this one, so if you've watched this video, then you'll be prepared for that. And in fact, one of the important things we need to learn about the secant and cosecant graph is what the differences are between them and how to determine what those differences mean. So we'll talk about that in class. So as long as my previous video was, this one's a lot shorter, thank goodness. And our next topic is about graphing variations of secant and cosecant. I'll see you over there.